In this video, we're asked once again about finding increasing and decreasing behavior and also, again, relative extrema. So the function we're given here is f of x equals 2 sine 3x. We're limited only to the interval 0 to pi. So as we've done before, first step, as is the case pretty much in most of what we do throughout this chapter, find the derivative. So that's pretty straightforward. Derivative of 2 sine 3x would be 2 cosine 3x times the derivative of the inside, which is 3, giving us 6 cosine 3x. We then ask the question, when is f prime 0? When is it undefined? Okay, so when is it 0? Well, it'll be 0 when 6 cosine 3x is 0. Which would happen when cosine 3x is 0. Now, a quick word about trig functions. When you have some angle in the side of the trig function other than just x or theta, we need to understand what's going on here and how far we need to go to find our solutions. The original variable is limited to the intervals 0 to pi. 0 to pi. But see, our angle is not x, it's 3x. So since x ranges between 0 to pi, then that would mean 3x, the angle that we're dealing with. The function for the angle here is going to have to range between 0 and 3 pi. So when we start finding solutions here for cosine 3x equals 0, we have to realize I need to find all the solutions that are between 0 and 3 pi. Now remember, 2 pi is one full turn about the circle, and so 3 pi would be another half turn. Okay, so at this point we draw our circle. The places where cosine is 0 on the unit circle occur on the y-axis. And so those would be, whoa, that was not supposed to happen. Not sure what button I hit there. So those would happen at pi over 2 and 3 pi over 2. I apologize for that. I think I hit the wrong button somewhere by mistake. And then that's one turn about the circle, but then we have to continue again 1.5 turns. So the next one would be coterminal with pi over 2. So we would add 2 pi onto that, or just add pi onto the 3 pi over 2, because it's a half turn away the next time. And then that would give us our third one, which is 5 pi over 2, or 2.5 pi. 2.5 pi is smaller than 3 pi. The next one would be 7 pi over 2, which would be, as we've went around, one full time, and then all the way to here. That's more than 3 pi, so it's not going to count. And then we just have to solve that for x. So we have to get rid of the 3 to solve for x. So we can think of that as divide by 3, or it might be easier to think of it as multiply 1/3. And we're going to multiply that across each one of those individual equations. So 1/3 times pi over 2 would be pi over 6. 1/3 times 3 pi over 2 would become pi over 2. The 3's will cancel. 1/3 times 5 pi over 2 would become 5 pi over 6. So those are all the places where f prime is 0. Where f prime is 0. We also ask the question, when is f prime undefined? But the cosine is defined everywhere, so f prime is never undefined, so that's not going to be a problem for us. So at this point we have 3 critical values. So let's go ahead and plot every one of those on a number line. And then we need to test a value in each region. Now, because this problem was in a limited interval to begin with, the endpoints on my interval are 0 and pi. 0 and pi. They cut the interval off. So my first value has to be something between 0 and pi over 6. So I might pick pi over 12. I pick pi over 12 because I can do that one in my head when I plug pi over 12 into my into my derivative here. I can do that one exactly in my head. You could take any numerical value if you want it, as long as you can take a decimal value if you want, as long as that decimal value falls between the decimal value for 0 and pi over 6. So I picked pi over 12, and when I evaluate that, 3 times pi over 12 becomes pi over 4. I know cosine of pi over 4 is square root of 3 over 2, and then that's multiplied by 6. So that actually becomes positive 3 square roots of 2. Okay, we then move on between pi over 6 and pi over 2. So I picked pi over 3. And when I plug that in, I'll have times 3. 3 times pi over 3 would be cosine of pi. Cosine of pi is negative 1. So that's going to be negative 6. And then pi over 2 to 5 pi over 6. 2/3 is between a half and 5/6. And when you evaluate that, you get that the derivative is positive 6. And then finally, f prime, I picked 11 pi over 12. 11/12 is between 5/6 and 1. And then when I evaluate that, I get negative 3 square roots of 2. But again, you could pick any value in those intervals. Again, decimal values are fine. All we're trying to do is get the signs on our intervals. So now we know it's positive in the first interval, then negative, then positive, and then negative. So as happens a lot of times, it does end up alternating, but again, not always. And so at this point, let me go in and highlight my positive intervals in blue, my negative intervals in red, and now we could go ahead and write down the increasing and decreasing behavior. And you might want to pause the video and take a moment and do that yourself to make sure you kind of have the hang of it. So when I do that, I'm going to say it's increasing the blue intervals, 0 to pi over 6, and pi over 2 to 5 pi over 6, keeping them open. And it's decreasing the red intervals, pi over 6 to pi over 2, and 5 pi over 6 to pi. Your textbook might put a bracket on the 0 or the pi, since they were included in that original interval. But again, usually increasing and decreasing, we stick with open intervals. So just be aware that may be a little hiccup on a homework question here or there. So just be aware of that. See how they're formatting things in their example, or to kind of see how you need to format yours. But generally, we keep them as open intervals. And then we look and see that, hey, it's increasing here and then decreasing on the other side of pi over 6. So as long as the original function is defined at pi over 6, that's going to be a relative max. So we have a relative max at pi over 6. When we plug pi over 6 into the original function, we get 2. We get 2. 2 times sine of 3 times pi over 6 will give us 2. And then notice we also have that same blue to red, increasing to decreasing, happening here at 5 pi over 6. So that's also another relative max, 5 pi over 6. And when you evaluate that, you're going to get 2 as well. You're going to get 2 as well. And then notice, lastly, we're decreasing and then increasing as we go to cross pi over 2. And as long as the function's defined there, that's going to be a relative min. It is. F of pi over 2, when we plug that in, is going to be negative 2. And so now we figured out when this function is increasing and decreasing, and also we found our relative maxes and mins.